All right, ladies and gentlemen, in this video we are looking at linear equations and we're continuing to look at how to solve them. I did have a video prior to this one that talked about the steps for solving an equation. If you haven't watched that video, go back and see that one first, or at least know that skill prior to looking at this one, because that's where we're starting here and I'm expecting you to know that. So starting off, let's take a look at this equation right here. In order to solve it, I am going to draw my line down the center. All right, and then I'm going to start by simplifying both sides. Again, I see parentheses, so that makes me want to distribute. Be careful in this case. A common mistake is for students to do 4 minus 3 first. That's not our first step. We've got to distribute that 3. This 4 stays put. Negative 3 times 2x is going to give me a negative 6x, and negative 3 times positive 1 is going to give me a negative 3. On the other side, I notice that I can put two things together. I've got 9x and x. Those are like terms. So 9x minus x is going to give me 8x, and this constant of 8 is going to stay the same. On the left side, it's still not simplified. There's two things I can put together still. This 4 and that negative 3 are like terms, and 4 minus 3 is going to give me a 1. So I'm going to end with 1 minus 6x equals 8x plus 8. Now to solve this further, I'm going to get all my x's to one side, so I'm going to move my smaller x by adding 6x to both sides. And at the same time, I want to move all my constants to the other side. So if my x is just left this left side going over here to the right side, I'm going to want to get rid of that 8 that's a constant over there, so I'm going to subtract 8 so that I can essentially move that over here. All right, give me 1 minus 8. Ultimately, I'm going to get negative 7 is equal to 8 plus 6 is 14x. And then I can isolate x by dividing by 14 on both sides, and I find out in this case that x equals negative 1/2. That is my solution to this equation. Why? Because that's the value of the variable that makes the equation true. And to prove that, you can always plug it back in. 4 minus 3. Let me just do a little separating there. And I'll even change my color for you. All right, that way you can track it. So as we look at this, I've got 4 minus 3, parentheses 2 times negative 1/2. All right, plus 1. And is that equal to 9 times negative 1/2? Plus 8 minus negative 1/2. Careful with that when you're plugging things back in. And you can take that and you can plug it into your calculator and see what you get. If you plug in both sides of your calculator, you should find that 4 is equal to 4. Therefore, negative 1/2 is the value of the variable that made this equation true. There's only one number that does that. That's why this is an equation with one solution. Negative 1/2 is the only one ever that will make this equation true. But what about this equation? All right, what if I start drawing my line down the middle here? I'll keep that line yellow, and then I'll go back to my white. All right, now if I go ahead and I start simplifying, I'm going to distribute my 2 on this side, giving me 8x minus 10. And on this side, I can combine some like terms, giving me 8x plus 3. And now everything's simplified on both sides, and I can start moving my x's. And I'm going to subtract 8x here from both sides. And notice what happens. When I subtract 8x, these cancel and these cancel, leaving me with negative 10 equals 3. Well, what happens when your x drops out? Wasn't I looking for what x equals, right? I wanted to find the value of the variable that makes this equation true. Well, when x drops out, that means that there's the same amount of x's on both sides. And so one of two things is going to happen. Either this equation will always be true, because both sides will always be equal no matter what the value of x is, or it will never be true. Ever, ever, ever be true. There's no value of x that I could ever put in here to make it true. How do you determine that? Well, you ask yourself one question. Is this true? And when I say is this true, I'm referring to the result left over after the x is dropped out. Is negative 10 equal to 3? In other words, is the left side equal to the right side? Is that true? In this case, no, it is not, and that's why there is no solution in this case, because there's no value of x that will ever make negative 10 equal to 3. How do we write our answer? Well, we don't write it with a question mark. There's two ways you can write your answer to no solution. One, you can use this symbol. That symbol technically means null. All right, it means there's nothing to input here. There's nothing to put there. So we were looking for a value of x that would make this true. There's no value of x that will ever make this true. And so that's one way we could state it. Another way is to literally write the translation and use the words no solution. Okay? Those are the two options that you can write. It is not acceptable just to do that symbol. That in and of itself does not mean no solution. X equals null, as we see here. means no solution. Make sure you write it properly. Let's take a look at a different example. This next one, as you can see, we're going to get infinite solutions, and let's see how that happens. Start off by solving it the same way we did before. We're going to distribute on both sides. 3 times 7 is 21, minus 3 times negative 4 is negative 12x. On the other side, the 17 isn't touched. We're just distributing the negative 4, giving me a negative 12x plus 4. All right, and if I continue to simplify both sides, I find that the left side is already simplified for me, but that right side I can put 17 and 4 together, giving me 21 minus 12x. Now right there, something might pop out. You might notice, hey, I've got the same thing on both sides. It is the exact same thing. 21 minus 12x equals 21 minus 12x. And the reflexive property of equality says that the same thing will always equal itself. So in this case here, we can already see that we're going somewhere where it's going to be a nice special case, but let's keep going. I'm going to keep solving by moving my x's to one side as if I didn't even notice that. So if you do see it earlier, you can stop and you can get to the right answer, but I'm just going to keep moving. And notice again, just like before, my x's cancel. But this time, I'm left with 21 on the left equals 21 on the right. And we're going to ask ourselves the exact same question that we did before. So this question right here that we asked, is it true? Well, we are going to ask that exact same question here. All right, is this true? And this time, oh, it didn't do it on me. Here we go. All right, this time we're asking, is this down here true? Is 21 equal to 21? That's what I'm looking at. All right, and is this true? Yes, 21 is equal to 21. It's not a trick question. It's the same exact number. It will always equal itself. That means there are infinite solutions here. That means x can be any value you want. You pick any value in the world and plug it in. It'll make this equation true. And we can say that by using this symbol. It's a capital R with 2 lines. I'm going to draw it again. Ready? For those of you who want to see it again. I do 2 lines down, and then I make a capital R out of it. All right? That is the all real numbers symbol. On a computer, you can often just use a capital R. That's fine. So you can write your answer like that, or you can literally write the words all real numbers. Either one of those is an okay way to write your answer. Okay, again, the symbol all by itself is not what we want. We either want x equals the symbol or write out the words all real numbers. But do yourself a favor, just test it, see it. All right, pick any number you want, plug it into the original equation, see what you get. All right, so you could just plug in 3, and then 7 minus 4 times 14 is what I'll put in there. All right, and then equals 17 minus 4 parentheses 3 times 14 minus 1. All right, take a moment, plug yours in. See. Now, I hope you did a different number other than me. All right, just to verify that any number in the world will make both sides equal to each other. Will make this equation true. And this, in this case, I got negative 147 equals negative 147. Now, your value would have given something different. That's fine, but it's still making both sides equal, and that's why this has infinite solutions.